Right, I carry on with the factorization of ax squared plus bx plus c, which is known as a quadratic expression. If you have watched my previous video, you know why it's a quadratic expression. Okay, now the first question I'm trying to tackle today is how to factorize x squared plus 5x plus 6. So the first thing I do, I will now show you what I actually do in examination, so that it's easier for you. So first, I will quickly sketch out my friend again, the multiplication frame. Okay, so notice, right, I just quickly sketch it out, no need to do anything fancy with it. Alright, so we have drawn the multiplication frame. First I put down x squared and 6. Alright, then now I try and figure out x squared is what multiplied to what. Quite simple in this case, is x times x. Okay, now this is the one that is the issue. 6, right, there are many ways of writing 6, right. For example, 6 can be written as 6 times 1. 6 can also be written as 3 times 2. So in this case, right, what I'll do now is to use a pencil. Okay, so I will try now to do this. Let's say I put 6 and 1 down here. Then I'll try 6 times x is 6x. 1 times x gives me positive 1x. Then I test it out here. 6x plus 1x is equals to 7x. Ooh, I think we have a problem. Notice that it is 5x here and this is 7x. So I have figured, right, that by putting 6 and 1, okay, I've actually made an error. It should not be 6 and 1 because the middle term doesn't match up. So that's why I did it in pencil. I can quickly just use my trusty eraser here and just quickly erase this portion here. Then the next portion here, I'll try again. 6, right, can be 3 and 2. So I write 3 and 2 here. Then I try it out now. 3 times x is 3x. 2 times x is 2x. So I erase the previous one. Then I test it out now. 2x plus 3x is equals to 5x. 5x and 5x, it matches up. So therefore, when I factorize x squared plus 5x plus 6, the reverse of it, okay, or the factorized form is simply x plus 3, x plus 2. And I have factorized x squared plus 5x plus 6. Now I shall do yet another question, okay, for you, which is x squared minus 9x plus 18. Ooh, getting a bit more complicated now. Okay, x squared minus 9x plus 18. So now simply, okay, just sketch the multiplication frame at the side now. I won't even bother using a ruler. Okay, quickly sketch it out. X squared, I write it down here. 18, I write it down here. Then quite quickly now, notice there are no more colors anymore. X and x, alright, I put it down here. Okay, there's no other way. 18, alright, 18 can be written in several ways. For example, 18 can be written as 6 times 3. 18 can also be written as 9 times 2. Alright, so I test it out first. First I say that I try 18 is 6 times 3. I write 6 and 3. 6 times x gives me 6x. 3 times x gives me 3x. 6x plus 3x gives me 9x. Okay, 6x plus 3x will give me positive 9x. Ooh, almost so close yet so far. This is positive 9x, this is negative 9x. Okay, so they are actually not the same. One is negative 9x, one is positive 9x. So I say, okay, this is not going to work out. Let me quickly erase this. Okay, so x and x again. So I try 9 and 2. 9 and 2. Similar, okay, 9 times x is 9x. 2 times x is 2x. So I write down 2x plus 9x is equals to 11x. Then I check 11x and negative 9x. Oh no, they're still different. Okay, so looks like I'm out of options already. What can I do? what we need to do here is to shift our thinking a bit. 18, besides being a product of two positive numbers, 18 can also be a product of two negative numbers. So instead of writing 6 times 3, I can actually try negative 6 times negative 3. Alright, then now here I will just erase away my values again. X squared and 18 remains. I'll try negative 6 and negative 3. So negative 6 and negative 3, negative 6 times x is negative 6x. Negative 3 times x is negative 3x. Then I test it out now. Negative 3x minus 6x is equals to negative 9x. And eureka! Negative 9x, I have confirmed that this factorization is indeed correct. I just copy out x minus 6, x minus 3. So the factorized form here is x minus 6, x minus 3. And I'm done with this factorization. Stay tuned for more examples of the factorization of ax squared plus bx plus c.